All right, today we're going to dive into a condition that affects millions of people all over the world, but a lot of us have never even heard of it. It's called thalassemia, and it's basically a hidden story written right into our DNA. So let's get into it.
I want you to just imagine for a second. What if the very cells that are supposed to carry life-giving oxygen all through your body just couldn't do their job right? What would that actually feel like? Well, that's the fundamental challenge for someone living with thalassemia.
So first, let's talk about just how big of a deal this is. This isn't some super rare one-in-a-million condition. No, this is a major global health issue, and it's got deep, deep roots in our shared human history.
Okay, so what is thalassemia at its core? It's all about hemoglobin. That's the super important protein inside your red blood cells that grabs onto oxygen and carries it around. Think of your body as having a hemoglobin factory. With thalassemia, there's a problem on the assembly line. The factory produces faulty hemoglobin, which leads to weak red blood cells that get destroyed way too early. And that is what causes anemia.
And look at this number, 4.4 out of every 10,000 live births. Now that might not sound like a huge number at first, but when you scale that up across the entire planet, it means thousands and thousands of children are born with this condition every single year.
But here's where things get really interesting. The risk is not spread out evenly, not at all. Globally, about 1.7% of people are carriers. But if your family tree has roots in the Mediterranean, Africa, or Southeast Asia, that number can skyrocket to as high as 30%. So why is that? Well, the leading theory is pretty amazing, actually. It's believed that carrying the thalassemia trait offers some protection against malaria. It's this incredible example of how our genetics are shaped by the geography of our ancestors.
Okay, so to really get what goes wrong in thalassemia, we first have to understand the recipe for what goes right. So let's take a peek inside a healthy red blood cell and see how this amazing protein is made.
The perfect recipe for adult hemoglobin is all about balance. You need two key ingredients, and you need them in precisely equal amounts. Those ingredients are protein chains called alpha globin and beta globin. It's like baking. Too much or too little of one thing, and the whole thing is off.
And check this out. This is a fascinating little switch that happens in every single one of us. When we're born, our blood is full of something called fetal hemoglobin, which is made of alpha and gamma chains. But then, around 6 months old, our bodies do this incredible switcheroo. They phase out the gamma chains and replace them with beta chains, making adult hemoglobin. That switch is a huge moment in our development.
And thalassemia is what happens when that recipe goes wrong. If you don't have enough alpha chains, or you don't have enough beta chains, either way, the whole system gets thrown completely out of whack. That imbalance is the root cause of all the problems that follow.
So this imbalance brings us to the two main types of the disorder. You've got alpha thalassemia, where the problem is with the alpha chain, and beta thalassemia, where the beta chain is the issue. Two different genes, two very different stories.
This table breaks it down so clearly. Look at the genetic cause. With alpha thalassemia, you're usually talking about entire genes being deleted from chromosome 16, just gone. With beta thalassemia, it's typically mutations, like typos, inside the gene on chromosome 11. And this difference has huge consequences, leading to very different worst-case scenarios. Hydrops fidelis for alpha and thalassemia major for beta.
Okay, so we've got the genetics. But what does this all actually mean for a person's health? Well, this is so important to understand. Thalassemia isn't just an on or off switch. It is a huge spectrum, from being a perfectly healthy silent carrier to having a life-threatening disease.
Alpha thalassemia is the perfect example of this spectrum. So we all normally have 4 alpha globin genes. If one gets deleted, you're a silent carrier. You'd probably never even know. Lose 2, you've got the thalassemia trait, maybe some mild anemia, but you're generally fine. But if you lose 3, that's hemoglobin H disease, which is a serious anemia. And losing all 4, well, that's just not compatible with life. The number of genes lost directly determines how severe it is.
Now, with beta thalassemia, the spectrum usually breaks down into two main realities. On one end, you have thalassemia major. This is the most severe form. Babies develop serious anemia and need blood transfusions for their entire lives just to survive. Then you have thalassemia intermedia. It's a milder form where people might only need transfusions every once in a while.
But those life-saving blood transfusions, they come with a huge catch-22. While they provide the red blood cells the body desperately needs, each transfusion also pumps the body full of iron. Over time, this causes a dangerous iron overload that can damage vital organs like the heart.
So on top of everything else, patients have to go through another tough treatment called chelation therapy just to get rid of all that excess iron.
So, facing all these challenges, what's the game plan? Let's take a look at how this disorder is actually managed, from treatments and prevention all the way to what the future might hold.
All right, let's run through the key strategies. First and foremost, genetic counseling is absolutely critical for at-risk couples so they can understand their options. A really important point, if you're a carrier with the trait, you should generally avoid iron supplements. For those with thalassemia major, those lifelong transfusions and iron chelation are the standard of care. And for some kids, there is a potential cure, a bone marrow transplant.
Okay, I really want to hammer this point home because it's so important. We've talked about some really serious stuff, but the vast majority of people who carry a thalassemia gene, those with the trait, are healthy. They live totally normal lives and don't need any treatment at all. It's just a piece of information about their genetic makeup.
And that brings us to our final thought. Thalassemia is passed down, written in our genes. And it's a powerful reminder that for conditions like this, prevention doesn't start with a medication or a procedure. It starts with knowledge. It starts with a conversation. So the real question is, where does that conversation begin for you? Thanks for joining me.